Okay, here's a good problem from the AP Level B physics exam from the year 2008. It indicates that there's two bumper cars. Car A is initially moving to the right at 2 meters per second, and it collides with cart B, which is initially at rest. Cart A is initially 15 meters away from cart B, and it starts out traveling with a speed of 2 meters per second to the right, and then it accelerates at 1.5 meters per second squared to a final speed of 5 meters per second. That doesn't require a full 15 meters of displacement. So the question goes on to ask, how much time will it take for cart A to collide with cart B? So part A is a problem in kinematics, so let's set it up. Whenever we solve a kinematics problem, it's helpful to make a list of the initial velocity, the final velocity, the acceleration, the displacement, and the time. So we're given that the initial velocity is 2 meters per second, and it's going to accelerate up to a final speed of 5 meters per second. The acceleration is 1.5 meters per second squared, and the displacement we have to find. It's not 15 meters. A portion of the 15 meters is covered during this period of acceleration, but once cart A reaches 5 meters per second, it maintains a speed of 5 meters per second before colliding with cart B. So let's figure this out. Let's find out how much time. All right. Okay, so time can be calculated from the kinematics equation that just says it's the change in velocity divided by acceleration. So the change in velocity is 5 meters per second minus 2 meters per second divided by 1.5 meters per second squared. And you can quickly calculate in your head that the time then works out to be 2 seconds. Let's go back and figure out how far it travels during those 2 seconds. So another kinematics equation tells us that displacement is average velocity multiplied by time. In this case, we can say the average velocity is 1/2 of the initial and final velocities added together because the acceleration happens to be uniform. Okay, so all of this means average velocity, and then I have to multiply average velocity times time to get displacement. So this is 1/2 times 2 plus 5 meters per second times 2 seconds. The 2 and the 1/2 cancel out. So, and the seconds cancel. So we're left with a displacement of 7 meters. So if we look back here at the 15 meters of displacement, the first 7 meters require 2 seconds of travel time, and then that leaves you with a total of what? 8 meters at a speed of 5 meters per second. So let's figure out the remaining time. 2 seconds to accelerate, and then we can just use the dirt equation. Distance is rate times time, so time is distance divided by rate. So we're left with 8 meters of travel at a speed of 5 meters per second. This comes out to 1.6 seconds. So all we need to do is to add the 1.6 seconds with the 2 seconds to get a total amount of time of 3.6 seconds. Okay, take a minute and review that, and we'll pick up with parts B and C of this problem in the next video. Let's pick up where we left off on this AP problem from 2008. We already found in the previous video that the time it takes for cart A to collide with cart B is a time of 3.6 seconds. Let's figure out the answer to part B. This is the part that's related to the law of conservation of momentum. So this is a two-body collision, and if momentum is conserved, that means the total initial momentum equals the total final momentum. The total initial momentum is the mass of cart number 1. I'll replace A with 1 and the symbol B with 2. Okay, so mass number 1 times initial velocity number 1 plus mass number 2 times initial velocity number 2 is how to calculate the total initial momentum of the entire system. That has to equate to mass of cart number 1 times its final velocity plus the mass of cart number 2 times its final velocity. So remember, we always use the symbol U for initial velocities and V for final velocities. So let's just plug in the values we know from here. 250 kilograms multiplied by 5 meters per second plus 0 because cart number 2 is at rest initially has to equal 250 kilograms times the value V1 that we're solving for plus 200 kilograms, and we're given that its final speed is 4.8 meters per second. This calculates to 1,250. I'm ignoring units because I know they're going to cancel as long as I'm consistent with the units. As long as mass is always in kilograms and speed is always in meters per second, the units are going to work out. It might be helpful for you to include the units in your own work. All right, 1,250 equals 250 V plus 960. So the velocity we're looking for is 1,250 minus 960 divided by 250. And this works out to a value of 1.16. And we're going to assume that the units are meters per second. That answers part 1, 1.16 meters per second. Part 2, indicate the direction of motion. Well, the initial momentum of cart A was 1,250 kilogram meters per second to the right. Cart B only accounts for 960 of those units of momentum to the right. So there's still a lack of overall momentum units to the right if we only account for cart B. So cart A must also be moving to the right. Part C asks us to investigate whether or not the collision is elastic, and we'll answer that question in the next video segment. The final question in this problem is to determine whether or not the collision is elastic. So keep in mind that in an elastic collision, there's no amount of change in mechanical energy. In other words, kinetic energy does not convert into thermal energy. So let's just compare the initial kinetic energy to the final kinetic energy and see how that comes out. The initial kinetic energy is 1/2 times the mass of cart number 1 times its initial velocity squared. And then I'm just going to say plus 0 because cart number 2 was at rest. This is 1/2 times 250 times 5 squared. And that comes out to 3,125 joules of energy. The final kinetic energy is twofold. It has to do with the final velocity of cart number 1 and the final velocity of cart number 2. So it's going to be 1/2 m1 v1 squared plus 1/2 m2 v2 squared. This is 1/2 times 250 times the value of 1.16 that we solved for in part B squared plus 1/2 times 200 times the given value of 4.8 meters per second squared. Hopefully you're working along with your calculator and you can verify that this portion works out to 168.2 joules, and the kinetic energy of glider B after the collision is 2,304 joules. So if we add those together, we find that the total final kinetic energy is 2,472.2 joules. When we compare that value to the initial kinetic energy before the collision of 3,125, we can see it falls short. So, there was some amount of kinetic energy that must have been wasted as thermal energy Mechanical energy then was not conserved. So we have to say, no, this is not an elastic collision. We would describe this as an inelastic collision. We wouldn't call it perfectly inelastic because the objects did not stick together.